This is the solar water desalination lab or activity. So I got all my supplies here. Large glass container. The closest thing I could find that was not as tall as this container was small shot glass. Unfortunately, that's the only thing I had, so hopefully that works. Spoon, 1 cup of water, half a teaspoon of salt, some small rocks for weights, and plastic wrap. So step 1 is to pour the water into the larger container. Okay. Add the salt and stir. Salt. And stir that up. Okay, now that that's all stirred, place the smaller container inside the larger container in the center. Oh, okay, it already is, so cover the larger container with plastic wrap. The wrap should not be touching the smaller container. Now that you have it wrapped in the plastic wrap, I needed both my hands to do so, so a little pause in the video. So now, step 4 is to add the weights to the center of the container. This is the location where water that condenses on the plastic wrap will gather and then drip into the smaller container. Let it sit out for 2 hours to several hours in the sun. The longer it sits, the more water will collect in the smaller container. Okay, so we're gonna go ahead and throw some of these pebbles here right over the shot glass. So all the water condenses and comes together in the center. I think that should be enough. Still, it's not touching the smaller container, it looks like, so the water should be able to condense and then hopefully drop into the smaller glass. So now I'm going to go ahead and let this sit outside in the sun for a few hours, and we will come back and see the results. So it's been about 2 hours. Just going to open it on up, and it looks like I got, let's say probably a tablespoon and a half, maybe 2 teaspoons actually, 2 teaspoons probably worth of evaporated water, the desalinated water that went into the smaller glass. It was pretty effective. I mean, I checked on it every once in a while. I think the first time I checked on it was only like 15 minutes after I put it out into the sun in my backyard, and I was shocked at how warm the glass bowl and the water was already after just 15 minutes out in the sun. I mean, granted I'm in Arizona, but still it wasn't out there for too long, and it was warming up pretty good, and there was definitely some, you could see all the water up on the roof of the plastic and kind of making its way into the smaller glass. So I thought it was pretty effective. So we're gonna go ahead and taste this water. Tastes kind of weird, a little salty. I think it's, so why does the desalinated water taste different than the tap water? That would have to be because the sun evaporates up the pure water out of there. So then what's left is the salt that's in the water, and then any minerals and anything like that was in the tap water to begin with. So I think that's why it tastes different. So the next question is to kind of discuss the operation of the still and use, in terms of thermal radiation and stuff like that. So basically, for this lab, for this experiment, the sun produced the electromagnetic waves. and those are in the infrared range, which then cause the thermal radiation. So this was done by the plastic, you put the plastic and it surrounds the dish, so the sun's radiation transmitted to the air, or through the air and water in the dish. Now, where energy was then absorbed and then transferred into heat. So both the air and the water molecules that conducted energy by transferring it to the other molecules. So this basically created the convection currents that transferred that heat to the remaining molecules. So over time, the transfer of those molecules caused the water to evaporate, turning into the water vapor, which then collects on the top of our plastic once it actually cools down. So the conservation of energy law actually states that the energy in an isolated system cannot be destroyed, but the state of it can be altered. So this is basically what happened with the liquid state of the water. It was transformed into the vapor because of that, and then obviously collected on top, and then because of the rocks holding it down, collected everything down on top of the smaller glass, which then dripped into the smaller glass. If the size and shape of the outer container affected the efficiency, I definitely think it would. I mean, this is I guess a relatively large dish for just 1 cup of water. But, if you were to have a larger dish, then the water would be dispersed over a bigger surface area, which just allows more surface area for those rays to hit and stuff. So the more surface area that this water is spread out over, I think it would be more evaporated water coming up. So I think with a larger dish on the outside that there might have been more water that ended up in the smaller container. The next question is how the depth or the volume of the water would affect the efficiency. And that's kind of the same deal, with a larger dish, we're assuming that you're going to use the same amount of water, 1 cup. So with a larger dish, with this dish, the water is, maybe a centimeter high, but with a larger dish, maybe it would only be, half a centimeter or 3/4 of a centimeter high in depth. So kind of the same principle, the more depth there is, that water that's underneath isn't going to get evaporated as quickly as the water on top. So the more surface area, the less depth, I think the more efficient this would work. So as far as any suggestions or improvements, I don't really have any improvements or anything like that. I would say, the best thing you could do is probably try different methods, like maybe try a larger container, and kind of take note of the differences. Like I said before, if this container was twice the size and that made twice the amount of surface area, I'm going to hypothesize that there would be double the amount of water in the smaller glass if I doubled the surface area of the dish. Other than that, you could try, different lengths of time. Obviously, if I would have left it out there for 4 hours instead of 2 hours, I'm assuming it would be twice the amount of liquid in the smaller dish. And then, also if you were to leave it maybe not in direct sunlight, maybe outside, but maybe under some shade, how much that would affect it. So there's a lot of different ways you can probably do some trial and error and things like that, and see the different outcomes. So that's about it. Thank you.